Hello guys, in this video I would like to explain about confidence interval in Python, that how we can plot, how we can perform to calculate confidence interval for the population parameter mu, and then we can display the results of the the constructed confidence interval for that particular parameter. Uh, but before this, I would like to explain something about what is meant by estimation and how you can estimate the mean value, and then how you can construct interval for that mean value, population mean value, by using sample data. So let's suppose that we have population, and suppose we have this, assume that the population is normally distributed with mean mu, that's the average value. We don't know about this. Then we can estimate that value by using drawing some sample from their data and calculate the mean value of their data, and we can set this is the estimated value of the population mean. Suppose you are interested to know about the monthly income uh, a particular age group of the female in the United States. Like you just assume that I need to know about the average income, monthly income of the United States for female of age 20 to 60. So the United States is a big country, and there's a lot of a large number of female in this age group. So that's not even quite difficult for students to collect the data from all those females of this age group to know their average income. The other way is to use statistical techniques, and you need to collect the data from some samples. You need to go to some states, collect the data for some number of number of female of this age group. Depend on your expenditure and the available fund for your project. You can collect the data, sample data, and then you calculate the average value of that sample data, and then you say, okay, based on this sample data, the average income of the United States of this particular group of female is this one. You will get some value. So this means estimation, estimating the average value of the population, of a normal population. But suppose I will say the mean values lie here, like the mean is written here. This is suppose the mean value, and then you can calculate. You can have different sample, like this is sample 1, sample 2, sample 3, and sample 4, and you calculate the mean values. You will see that the first mean value is not far away from the mean value, so is not exactly equal to the population mean. Similarly, the mu, the sample mean of the second sample, that is x2 bar, this was x1 bar, this is x2 bar, it is close to population mean, but still away. X3 bar is near, exactly, almost exactly equal to the population mean. X4 bar is far away, and yes. So the one way is to overcome this issue, we can calculate lower and upper confidence limits for the sample mean based on the sample data. So you can see that these are the limits, lower limits, and this is the upper limits, and you can see that the limits have the population mean mu. Similarly, this is the lower limit of the x2 bar, and the population mean mu, the estimated lower limit and the estimated upper limit, and this is the sample mean, and this can have now the population mean. Just look at this, is cover this population mean. Similarly, mu3, similarly the third sample, that is this one, and the fourth sample does not have the population mean mu. Even the confidence interval don't cover the population mean mu. Okay, so this is the concept of confidence interval. Then how we can do this? This is the question. Now you can see that we are using totally the sample data and the quantile from the standard normal distribution. Just look at this. This is the sample mean, and we just add the margin of error and subtract the margin of error. So when we subtract the margin of error means sigma divided by n, or z alpha by 2. By the way, mostly we don't know about the population standard deviation, so we use t-distribution instead, like this. So this is the sample mean, or plus minus t alpha by 2 n. N is the degree of freedom. Normally this is n minus 1. By the way, it is mentioned n minus 1 here, so this should be n minus 1. The sample standard deviation and the square root of the sample size. So we are using all the sample information using some quantile from some value of the t-distribution with this particular significance level alpha by 2 and with n minus 1 degree of freedom in the sample size. you can calculate lower limit and upper limit. For example, lower limit is x bar minus t alpha by 2 n minus 1 s divided by n square root. So this is the margin of error which is subtracted from the lower, from the mean sample value, from the sample mean, and that's max lower limit for the population mean mu. Similarly, you need to add the margin of error to the sample mean x bar, that is t alpha by 2 n minus 1 s divided by n square root, and this makes the upper limit for the the estimated upper limit for the population mean mu. Of course, this is the lower limit, the upper limit of the sample mean x bar, and this is the lower limit of the sample mean x bar, but these are the estimated values for the population parameter mu, main value. Okay, this was some theoretical background, and now we can see. You can see these. This is the this is the plot. You can see here. I would like to maximize this further. Okay, now I'll explain one of them. Let's suppose the first sample is, look at this. The blue line start from here and here, and the dot line, this is the sample mean. Remember, of this sample, the dot line is the sample mean of this sample. This is the sample mean. By the way, this is the population mean. The green line is the population mean, and you can see that the sample mean is far away from the population mean. It is at near to 48, and the sample mean, the population mean is 50. But the confidence interval that's cover this population mean. Similarly, this is the sample mean for the second sample, and so on. And look at this. The red color, this does not include the population parameter. That's why this is colored with the red color. And just look at this. Look at this. This dot line, this black dot line is the sample mean of this sample, and the confidence interval, the interval are from low, upper interval and lower interval, and this does not include the population mean mu. Okay, so this means that we have drawn 100 sample from, look at this, 100 sample are drawn, each of size 30, and then 95% confidence interval were calculated, and you can see that 90 samples have the mean value, cover the mean value, but 5 of them, 1, 2, 3, 4, 5 of them does not cover the population mean mu, that is represented by the green line here. So this means that this is the definition of the confidence interval. When you draw 100 samples from population and calculate 95% confidence interval for each sample, 5 of them will not include the mammalin, because the population mean, and 95 can have the population mean. So that's what what is mean by 95% confidence interval. That's you can explain for 100 sample in this easy way. This is another interpretation of this. There's some interval calculated for this region and for this region, and yes, so the mean value, yeah, this will cover like this, m is greater than this one and this one. So look at this. Now it is explained here. This is the mean value, and look at this. This cover the mean value, by the end is like here, okay, and this cover the mean value. The fourth sample cover the mean value, but this line, the third line, which is represented by the red line, does not cover the mean value. Okay, so now let's see. This was just theoretical background and interpretation. Now let's see how we can do this in Python. Just look at this. We are okay. There's some required libraries or some function which we need to import, and then we have the data. Sorry, I forgot. I will just need to open the book from which I took this data. I think this was okay. Example data. I need to open that. Okay. Just wait. I'd like to open their book, because that's very important to know how we can solve the problem from the books using. Okay. This is okay now. Okay, I will find it now. Yeah, that's important to know, because the undergrad student can learn how easily they can solve these problems using Python or any other software. This which you can see now the content. This is a very nice book. You can see for undergraduate students. Other students can also learn from this book. Children Rose Introductory Statistics, 3rd edition. I will show you the content briefly and then just look at the content. There's introduction to statistics, describing data sets, using statistics to summarize data sets, probability, discrete random variable, normal random variable, distribution of sampling statistics, and estimation. That's the point which we are talking about today. So we are interval estimations. We are talking about this. Okay, so let's see. 357, so 347. Let's jump to 347 and then see where's that example. So, oh, that's really nice. We're just reaching near to the point. Okay. Okay, I took this example from the book. Yeah, this is the example, I think. Okay, so let's see the data 16002391, 16002391. Okay, this is the example. Okay, so you can see this example is taken from this book. The Environmental Protection Agency, EPA, is concerned about the amounts of PCB, a toxic chemical, in the milk of nursing mothers. In a sample of 20 women, the amount in part per million of PCB were as follows. Like, these are the values of 20 females nursing mothers. Use the data to obtain the 95% confidence interval, 99% confidence interval of the average amount of PCB in the milk of nursing mothers. So this is general about all nursing mothers. Based on this sample, you need to construct 95% confidence interval. Okay, and 99% confidence interval. So this is the data, and we will solve this problem in Python, and then we will see the answer, because this is example and this is solved on the next pages. So this is the data. Let's see, describe. Okay, just the data is stored in the data now. Our mean as np.mean data. So this will calculate the mean value, and this will calculate the standard deviation of the sample data. We don't know about the population standard deviation, so we can use t statistic, of course. Okay, now confidence as the confidence limit level is 95% in this example, in this point here. Do this, and then this will calculate the confidence interval. Ci state.t.intervals. This is the function which you can use, and this is the confidence. That's the confidence level is 95. D if len data minus n. This is the degree of freedom. Count the data minus 1 degree of freedom. That is n minus 1, which you learned just earlier. Loc, that is location, that is the mean value, which is calculated from here, mean value, and standard deviation, that is SEM, standard deviation. Okay, calculated, that is scale. Do this, and that's all about calculating the confidence interval. Now you can print the results by using this. That will print the mean value. So this, the mean value is 5.80, and now you can calculate, you can print, not calculate, 95% confidence interval. The 95% confidence intervals are 3.42, the lower, and 8.18. 3.42 and 8.18. Now let's see this in the example. Okay, so this is some calculation, and it is given. That is, we are 95% confident that the average amount of PCB in the milk of nursing mother is between 3.42 to 8.18. 3.42 to 8.18. So this is what it is mentioned in the book. You can solve many problems from the books using Python and R very easily. So this was the first part. Now the second part is 95%. You don't need to do anything. Just change this to 99%. Confidence to 99%, and do this step again, and then display the results. So we have done this here. That is 99%. You will see the change now. So again, do the same thing, because you have changed the confidence. Now here you can do this. Now friend, the mean value is the same, but confidence interval can be different. 2.55 and 9.05. 2.55 and 9.05. Look at this, 2.55 and 9.05. And we can be 99% confidence that It is between 2.55 and 9.05 part per million in the Milcap nursing model. That's mean the PCB amount. Okay, so this is all about how you can calculate confidence interval, in Python. Okay, I have done this now. And now you know how to plot these data sets. I know the plot which I shown to you like this. How you can plot this? Look at this. We can do this. This is a code which can calculate. You need to import these libraries. That's important. And now you can do this. You can have some statistics. We are not doing from that example, but you can do from that example as well. This is population mean, that is 50, population standard deviation as 10, so that is suppose known. Sample size is 30, number of samples we draw 100, and we calculate 95% confidence interval for that sample data, and then we will display those all 95% confidence interval. Okay, so this is all about mean value storage of the mean and confidence intervals. Mean will storage this. A lower limit will store lower limit, and upper will store upper limit. And now this is, they will now draw the samples in range of n samples, that is 100 samples, np.random sample. They are drawing now 100 samples. Okay, location, that is the location, scale means scale, sample size of course 100 per each sample, that is mentioned here. And then they're calculating sample mean per each sample and standard deviation per each sample, and then confidence interval per each sample. So this loop doing this stuff, and the mean that appends. So this will append all the means from the samples, and this will store the lowers, the CI lowers and CI uppers in this. Okay, so then you can plot. This is all about calculation, and then you can see, you can run this as a whole, and you will see a nice plot. Just run this, you will see. Okay, just look at the plots. Okay, what is happening? Okay, name means is not defined. Okay, let me check this. Oh, okay, this is not, I have not run this, so now this will work. Look at this. Yes, that's okay. Very good, it's functioning now. Just look at this. You can define, you can explain this figure now in detail. Okay, so you can bets. Okay, so look at this. These blue lines are, the confidence interval for each sample, and the dark blue dot as the sample mean for each data, and the red color, that is true mean, that is population mean. So you can see how many sample covered the population mean. Look at this. This not covered, this not covered, and this not covered, and this there can be others. So this is one of them to plot. 95% confidence interval per 100 samples, n is 30. You can do this now. You would like to color the samples which does not cover the population mean with a different color, and that I have done in the next, this in this code. You will see now the samples which does not cover the population mean will be colored with the red color. Let's look at this. Okay, true mean, that is the population mean with the green line. And just look at this, 95% confidence interval for 100 samples with each sample size 30. Just look at this. I have explained this already, so you can see, you can represent these nice results, and you can explain, when you're working some company job or something like this. Okay, so what we have learned what is confidence interval, what is estimation in fact, and then what are confidence interval, and then how you can calculate this in Python, and how we can visualize, effectively these confidence interval in Python. So I think this is enough for today. See you in the next video. Ciao.